Okay, so now that we've looked at all of these things that we kind of found about sets, so how to list a set, the different symbols, the subsets, now we want to look at one of the other representations of a set, which is a diagram, and it's called a Venn diagram, so named after the mathematician who kind of, I suppose, discovered them or kind of popularized them, if you like. So the Venn diagram, it's a visual representation of a set, and really what it boils down to is that in a Venn diagram, a set is represented by a circle. That essentially is what it boils down to. So every set is represented by a circle. If an element is in the set, it will be in the circle. If it's not in the set, it is not in the circle. Okay, and it really boils down to that. There are some smaller parts we use in terms of kind of filling out those circles and kind of how we do it, or how, yeah, the way that it's done. But at its core, the circle represents the set. If you're in the circle, you're in the set. Okay, it kind of takes the place of the brackets that we had for listing the elements. Obviously then, when we're working with a diagram, okay, and when we're working with sets, even generally, we've seen in some of those questions there that it's usually not just one set that we're looking at. We're maybe looking at a combination of sets. We've multiple sets on the go. And the same is going to be true with our Venn diagrams. We're going to have multiple sets, and we're kind of going to look at how they interact with each other, how we maybe put two sets on the diagram, and do we have to then consider any other parts or any other kind of characteristics when we do that. So the first three things to look at here are just the three bullet points, which just describe our Venn diagram. As I've said, each set is represented by a circle, and I've just added there that the name of the set is usually written in capitals, and that's the same as we had before. It's typically written outside as well. The elements of the set are written inside the circle, and I have a note there where we said that they have a dot beside them as well. So we usually put a dot, quite a clear dot beside them. That again is to distinguish the elements of a set. It kind of is similar to how we use the commas when we were listing them out in a list. It's just maybe to separate individual numbers, to make it really clear what each individual element is, to make it clear that if I have 1 and 2 in the set that it's not 12 just because I've written them very close to each other. And then again, as I said, if it's in the circle, it's in the set. Okay, in terms of the relationships, okay, when we're drawing our Venn diagrams, we're typically going to draw them like the example we have here, where we have two sets kind of overlapping, two circles overlapping each other. And the reason for that is what we've seen in a lot of the sets we have so far is that there's often elements that are common to two sets that are found in both. And the word that we use for that is called the intersection. So the intersection of two sets is the set of elements that are found in both sets. And the symbol we use is kind of like an N shape, and we put it between the two sets that we're talking about. So for example, written out here, A intersection B, that is the set of elements that is in A and B. Okay, if, like we have in the example here, we have one set which is 1, 2, 3, and another set which is 3, 4, 5, the one element they do have in common is 3. And that, I suppose, we would list out, as we've done there, in terms of our diagram, that 3 would be found in the middle here. Okay, the reason that is important is that is the part of the diagram where 3 can be written so that it's in both circles. And we said that was really important, is that if something is in the set, it is in the circle. Okay, so we needed a section where elements could be put and be in both circles. Okay, that's essentially what it boils down to. Continuing on a little bit beyond intersection, we can look at union. So the union of two sets is essentially everything contained across the sets. So it's something that is in A or maybe in B, or it could even be in both. Okay, so it's allowed to be in both, but it just has to be in at least one of them. So it's in A or it's in B or it's in both. Sometimes we think of kind of this as like it's the two sets all together. So taking kind of everything that is across the diagram nearly all together, or across those two sets. So using the same two sets we had, 1, 2, 3 and 3, 4, 5, then A union B is 1, 2, 3, 4, 5, the entire combination of the two sets there. And the symbol for that is a U symbol for union. Okay. Keeping going then, the universal set, and this, I suppose, similar symbol, this uses the symbol of a capital U. Okay, so we'll just put a little note to make sure we remember that that needs to be a capital. And the universal set is like the background set. So it is the set of elements that are being considered. So that might be, if I was looking at different sets like vowels or the set of letters in your name. The universal set could be the alphabet. It might be all the letters I could choose from. So even thinking of, let's say, for example, sometimes people would use the example of Scrabble. Okay, if you're playing Scrabble, you might say that the set of letters you have is one set, then the set of letters that someone else, one of the other players has, that's another set, and then the universal set in that case would be all the letters in the box. Okay, the entire kind of amount of letters that were there. So it's everything within the rectangle. So you can see in the diagrams we've had there that there hasn't just been the two circles, we've also had kind of a rectangle around the outside, and that rectangle represents the universal set. So that is the set of everything in the diagram there. And what that gives us is it gives us a place to put the things that are not in either set, and that's going to be very important for us. The last little thing to look at is what we call the complement, and the complement of a set is denoted by a little apostrophe, or sometimes a little c. And how we would read it is you read it as not a, not a. Okay? It is basically just the set of elements that are not in set A. So if I have a full set like this, where it's 1, 2, 3, 4, 5, 6, and A is the set 1, 2, 3, then A complement is just the set of elements that are not in A. So actually not 3 there, that's a mistake. Shouldn't be 3, obviously 4, 5, and 6 then are the set of elements that are not in A. Okay, so it's just a way of us maybe looking at a certain portion of the diagram or excluding a certain portion of the diagram. So all four of these are very, very important when it comes to using our Venn diagrams and denoting our sets using a Venn diagram. So we're going to get stuck into that. So plotting a Venn diagram, when we're drawing a Venn diagram, where we're going to start from is we're going to start from the middle, the intersection. Okay, that's the things that are in both sets, and then we're going to work our way outwards. The reason we do this is it makes most sense to start with the things that are going to be in both sets to make sure that we don't accidentally list them multiple times. So we just start with the things that are in the middle, we then work our way outwards. So find the elements in the intersection, then A only and B only, then the universal set, and then we fill them all in. So usually take a minute to work out what's going to be there first, then fill them into your diagram. And then we just add them up to make sure that we get the number that we needed in the universal set. So my universal set here is the numbers from 1 to 12. So let's even just list them out. 1, 2, 3. Just so that we have this to kind of work from when we get stuck into our Venn diagram. The next thing I would do is look at the two sets P and Q, because these are the two sets I'm going to be representing. And I'm looking to see are there any elements that they have in common. So even just straight away, we can see they both have a 1. P has a 2, but Q doesn't. They both have a 3. They don't share a 5. They don't share a 4. They don't share a 5. They don't share a 6 or 9 or 12. So only those two elements of 1 and 3. So now that we've kind of done the prep work there, I feel that we're ready to start onto our diagram. Okay, so I'm going to start here drawing my rectangle with my capital U. So remember the capital U there is the universal set. That's the background set, that's everything. That's the overall kind of situation we're looking at. For this question, that's the numbers from 1 to 12. So they're the only things that matter. They're the only things that exist for us right now. We're going to start with the section in the very center, because that is the section for the intersection. That is where the two sets cross over. Anything I put in here is going to be in both circles, so both sets. So for us here, that needs to be 1 and 3. They're in both sets, we need to include them both there. The next thing I would do then is look at the elements that are left over in the set. So for P here, that's 2, 4, 6, and 12, and for Q, that is 5 and 9. So we're nearly there. We've listed out all of these elements. Okay, if we look at what we have here, if you ignore the part of P on its own and only look at the circle Q here, we have 1, 3, 5, and 9, which is what we needed. And if we do the same with the circle Q and only look at the part of P here, we have 1, 2, 3, 4, 6, 12, which again is what we needed. We do though have to consider the numbers in the universal set. So 1 is on our diagram, 2 is on our diagram, 3 is on our diagram, 4 is, 5 is, 6 is, 7 is not. So it needs to be included. So we're going to put it not inside the circles because it didn't appear in either of those sets. Okay, it's not in P and it's not in Q, so it wouldn't make sense okay, or it wouldn't be correct for us to include it in either of the circles there. Where we would need to put it instead is going to be on the outside of the two sets. Okay, so instead of putting it inside the circle there, it's going to be included on the outside. The same is going to go for any other elements that we have that have not been included in the diagram so far. So we're talking about, say, 7, we're talking about 8, 9 is included, we're talking about 10, and we're talking about 11. The last step we said was to count these elements and make sure we've included all of them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there were 12 elements in the universal set, so there should be 12 elements on our diagram. Then we were just asked to list out these individual parts. This first symbol we have here, the little U symbol, the small u means union. It's just in P or Q. So we're only looking at the things that are included in the diagram here. Again, I'm going to make an effort, if I can, to do these in order. Just makes things easier for both myself and a potential examiner. The next symbol here with the N, that means intersection. So that's going to be just this section in the middle here. And that's just going to be 1 and 3. And lastly, we're asked for P complement, so the set of elements that are not in P. So that is going to be everything except the circle P. So everything I'm highlighting in pink here is in not P. So we're looking at 5, 7, 8, 9, 10, and 11. So notice how we're not even including the 1 and 3 because they are in P. So just everything else. Okay, so we'll hop into some of these questions. We'll fly through some of these. Usual story. If you haven't looked at these questions yet, don't just watch through them, okay? Give them a go for yourself first. The main thing really is to make sure you're following our steps here for listing our Venn diagrams and that you're also happy with what all the symbols mean here. Okay, and working through those questions is going to make you more familiar with the symbols, but you do just have to maybe study them first, try and learn off what they all represent here. But let's just look through these questions quickly. 6 students were in a class were asked if they ran or cycled during the midterm. The Venn diagram shows the responses. Name one student who ran. So we're looking at anyone in this circle here. So anyone at all, we'll go with Tim. Explain what the following statement means. It says the cardinal number of C is 3. So there are 3 elements in set C. Set C was the number of people who cycled. So it's 3 people cycled. Let's go into the next one. Name one student who is in the region or NC. That's the intersection. So the intersection is this part in the middle. Again, that's Tim or Denise. Let's do Denise this time. Highlight this here. And lastly, one student is picked at random from the 6 students in the Venn diagram. So this is where we tie some probability into our Venn diagrams here as well. So one student is picked at random. Write down the probability that this student ran during the midterm break. So we should hopefully remember from our work on probability, to work this out, I need to look at how many students ran. So that's how many students are in set or, that's 4. So 4 students ran out of how many students? Okay, so it's always important to keep it as a total. So 4 out of 6, which is 2 out of 3. We always write down our answer as simplified as possible. Okay. Let's get into some more questions here. We have a practice question where we're looking at some multiples of different numbers. So I'm asked about the multiples of 4 here. So let's list those out. 4, 8, 12, and 16. And B is the multiples of 3, 3, 6, 9, 12, and 15. I'm only going that far because the universal set only goes up to 16. So there's no point in me including numbers larger than that because they're not contained within this rectangle. Okay, so let's look then. As we said before, we look and see are there any numbers that are shared, and in this case it's only 12. So then I can fill in all the other numbers. 3, 6, 9, and 15. And then I need to list some numbers outside. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14. Okay, we're then asked to list the elements of each of the following. A intersection B, that's this section in here, so that is just 12. I'm listing elements, so I still make sure I use my brackets. A union B, that is everything across the circles here. So anything inside this kind of blue line that I've drawn is in A union B. It's the two sets put together. So 3, 4, 6, 8, 9, 12, 15, 16. B complement means not B. So anything that is not in B. So we're looking at like 1, 2, 4, 5, 8, 7. Okay, as he said, we try where we can to maybe keep it in order, but if not possible, we don't. And I need to make sure as well that I don't forget my brackets there. And then A union B complement is anything that is not in A union B, so that is everything on the outside. Lily is going to pick a number at random. Calculate the probability she picks each of the following, or the number she picks is in each of the following. The probability the number she picks is in A, well, there are 4 elements in A out of the 16 numbers she could choose from, so she has a 1 out of 4 chance of picking that. The probability it's in the intersection, there's only one number in the intersection, so she has a 1 out of 16 chance of picking that number. And the probability that it is in the A union B complement, so the outside, we'll count that up. 1, 2, 3, 4, 5, 6, 7, 8. She has an 8 in 16 chance, which is a 1 in 2 chance, a half. The probability of her getting that is a half, so fairly high. Let's look at the last 2 questions here. This question asks us to fill out the diagram first again. So same idea again. Let's start with what's in the center. So what do they have in common? They each have O, I, and A. We then fill out the extra parts. There's actually no universal set for this question at all. So we're getting off a little easier. We're asked to write down a subset of X that has 2 elements and is also a subset of Y. That's going to have to be a subset made up of the elements that are in the intersection, because the only way they could be in both sets is that they were in the middle. So we could do O and I, for example, or O and A, or I and A. A subset of X that has 2 elements that is not a subset of Y. We could do N and C. We could do N and L. We could even do N and O. Okay, or we can keep going that way. Okay, any subset that is not an answer to the first half, really. So let's put in the 3 answers to the first half there. So we had 3 answers for the first half, and for the second half, anything else. Anything else at all. Let's look at the last, I think this is our last one here. So D, Marie, or Moira, Ray, Evan, and Fiona all use Snapchat. D, Moira, and Ray use Twitter, and Zach doesn't use Snapchat or Twitter. Use the information to complete the Venn diagram. So again, we start in the middle, we look at the people who use both. They've listed them out actually quite nicely for us here, because they've actually listed them out in order, so we can fill them in quite easily. Evan and Fiona are over here. And Zach needs to go on the outside because he doesn't use either. We'll just make sure we include our dot with them as well there. Okay, interesting to look at this set because we see that there's actually nobody who only uses Twitter. Interesting to note already. List the elements of the following. The intersection, okay, we should be fairly okay with that now. That's the people that are in the middle. I'm just going to kind of abbreviate them there. And S complement, that means anything outside of S, which would be all of this part. So that's actually only per old Zach on his own. And then we're asked to answer the following questions. The first question says hash S equals 3. So we remember the little hash symbol means how many elements. It says that there are 3 elements in S. We can see that that is false. There are 5 elements. There are 5 people who use Snapchat. The next one says that D is an element of T, that D is in the set T, the people who use Twitter. That is true. It says S union T is equal to T union S. That's going to be true. If we take all the people in both sets, they're the same as taking all the people in both sets. And then lastly, T is a subset of S. So remember, a subset means a set, usually a smaller set, that is contained within a bigger set. So is everything in set T found in set S? And we can see here that it is. There's no part in T that is not included in S. So that is true also. Okay, so working with our Venn diagrams here, the key things, as we've said, are to be sure of your steps here in drawing those diagrams, and to also be confident with your keywords and notation here for all of those possible relationships between our sets. If you've got those understood and you understand how to draw your diagrams, you should be able to fly through those questions there and really any question on sets.